Okay, let me do this first before I actually start, because I forget if I did it or not. And this week's already turned into a mess. That's only Tuesday, I think. Um, when I was talking about, I think I ended up with the GMO stuff. I'm not sure if I got it sustainable yet. When you're looking at things like sustainable agriculture, it's really, really tricky. It's a huge deal right now with the state of Hawaii. The state has decided that sustainability in terms of food production is absolutely critical. We're actually one of the worst places in the world. We import roughly between 94 and 96% of our food, and we produce basically nothing in Hawaii. And ironically, what food we do produce, or at least their agricultural products, would be things like Kona coffee and such, which is for export anyways. So what agricultural lands we do have, the stuff that we produce is generally not consumed here. The papayas grown in Wahiawa, for example, are shipped to Japan. So even the agricultural lands that you have aren't designed for local consumption. Something that's become a real obvious issue with the whole COVID crisis and farmers suddenly having to sell their product here when they normally depended on export, and sort of getting into a panic because they had never had to actually try to sell it to you guys. And so they'd never bothered to tell you guys, oh, by the way, we grow this here. So it's been an interesting learning process. The sustainability as I think I might have mentioned earlier in this semester, is actually a fiction. Sustainability is a really tricky concept, but sustainability sort of has two parts to it. One is there's just the sustainability of being able to do something within the resources you have available, which is like the basic definition. If you're really talking about like sustainable agriculture, what you're talking about is the ability to sustain it over time. So it's not just having the water and the land and whatever else is you need to grow X, for example. It's that you need to be able to do that over years. And that's where it gets really, really tricky and very, very complicated. And pretty much all the green revolution changes that have occurred in agriculture and food production have actually worked against sustainability because they were invariably increasing yield. So you get more food for plant, or if it's something like chickens, you get more food per chicken, more meat per chicken. But in doing so, you're moving it further away from whatever the original form of that particular thing was, a plant or an animal that could actually subsist on what was around it. For example, a chicken that walks around the backyard and just eats stuff. If you were to actually take one of the chickens, we only have one place that raises the chickens here. It used to be down at Sand Island. I'm not sure. I think they raise the chickens down in Wahiawa somewhere, but I'm not sure exactly where it is. But if you go to the mainland, they have these enormous chicken, I think they call them chicken farms. I don't think they call them much of anything else, where they raise maybe 10, 20, 30,000 chickens at a time in these huge warehouses. And in that situation, if those chickens, for example, are actually been genetically modified so they can't really walk. So many of those chickens really can't stand up because they're living in a small cage all their life. So they don't want the chickens to develop strong legs, because then they try to kick their way out and they might injure themselves and the chickens next to them. So you actually modify the chicken so it's basically just a lump. You modify it so that what foods you feed it, it can actually process more effectively so that it develops more meat more quickly. So a chicken that you raise in a box right now takes, I think, 1/3 the time that it takes a chicken that you see wandering around, say, KCC. Since there's a bunch of chickens running around there. As far as I can tell, look like they're all ex-fighting cocks. But I mean, those would take, little cutie boogers that turn into chickens would take months. In one of those boxes, in one of those warehouse things, it would take just a couple of weeks. And that's all fine as long as you're trying to generate more protein, more chicken meat. But it also means that if you were to actually let those chickens go, if you're going to sneak in the middle of the night because you're going to save them from being in a box and let them go out and live like this in the world, what you're going to actually find is those chickens will die. They actually can't survive in an area, even if you're hand feeding them. They don't have the ability. They've become physically incapable to do that. So just like tecate turned into maize and corn, we're modifying some animals to the point where they're no longer functional, even in a controlled environment, unless it's the particular environment they're designed for. And that moves you further and further away from sustainability. As I think I might have mentioned last time, when you look at sustainable agriculture here in Hawaii, And the state's spending a bunch of money on this. It basically, the current estimate, at least from archaeologists like me, who are also geographers, is you could probably sustain about 15 to 20, maybe 30,000 people on the island of Oahu. The current population of the island of Oahu is 980,000, which means 950,000 people couldn't stay here. There's not enough water. If you don't have pumping stations and such like that, you've only got water for that amount. The amount of land that you can actually turn into agriculture right now is about that amount. But that would also involve changing all the agricultural lands from whatever you've got currently growing to sustainable, basically, plant production. So when you look at sustainable agriculture, it's incredibly popular as a discussion point, especially in areas like here. Singapore is another case in point for very much the same reasons. Your population is a lot larger in your land area. But the reality is sustainable agriculture is maybe in some cases more like hoping that Santa Claus is still around than something that's actually achievable. For the amount of money being put up by the state for sustainable agriculture, it's hard to really see where they're getting, any bang for your tax dollar, to be honest. And that doesn't seem to be changing. So sustainable ag in some areas is a realistic proposition. In other areas, and in fact, in most areas, it's a very popular, very attractive notion that really gets people going because it seems like such a compellingly good idea that you would grow your food locally, you would harvest it locally, you'd consume it locally, and your impact on the global energy, pollution, et cetera, concerns would drop down dramatically. But the reality is, given the huge population of people on the planet right now, and the type of things that we like to consume, the amount of protein that we consume, and for example, cattle and chickens and stuff, and the type of foods that we like to eat, it's not really very realistic, to put it mild, even at a global level, much less say a national level, and certainly at the level of the Hawaiian Islands, it's not happening. Some of the outer islands could probably survive. Molokai might be able to survive with maybe half of its current population. Maui, the Big Island actually would be the most sustainable if you completely changed how you ran the island and did everything on it. It could probably actually carry the population it's got now after about 15 years of modification. The other islands are in not as good shape, in Oahu. It's just just ain't happening type thing. So when you see discussions about sustainable agriculture, and again, remember, it's something that's hugely popular. I suspect that both folks running for mayor have got this in some sort of a platform. Anyone running for governor here is going to, because basically all of the stuff that's imported to Hawaii comes via Matson. So it's all part of a monopoly. So everything that's shipped to Hawaii basically comes from one company who can, of course, at some point pretty much charge what they want. So that's one reason why there's this huge motivation to be sustainable. But the whole rhetoric of what is it called, farm to table, I think is the term they're using now for sustainable agriculture. It's really pretty equivocal if you actually look at how much that's actually sustainable in the sense of a longitudinal period of time thing versus more locally grown stuff in sort of a vague general sense. So just sort of keep that in mind. It's just such a hugely popular topic now. That's always important to sort of remember where it's coming from, and also frequently not exactly what they're not really bringing up in the discussion, because I don't think in some cases people want to hear it particularly. So resources, which is what I want to go over today, and actually energy. When you're looking at resources, this is a really strange concept. I forgot to do this. Let me do this on the side while I'm talking about this before I forget. When you look at resources, and especially here when you're looking at things like minerals or water, one of the huge problems you get into is that through most of world history, places could pretty much do what they did with not too much concern about the consequences of it, because it really, for one thing, the population was so small. There were so few people that you really had to work really, really hard at messing stuff up for folks outside of your area, because we just didn't have the technology to do it effectively. So you could pretty much make a mess of your own backyard, but you really had a problem making your mess of the backyard, say some group, 1,000 miles away. So it really wasn't an issue for most of world history. In the last couple of hundred years, especially with the growth of industrialization and more advanced engineering and stuff, these changes have been able to happen. But all these changes occurred during a period of colonialism and in a period when countries became incredibly aggressive and more focused on providing for the people in their own country. Now, because colonialism was a big part of this, what it meant is your own country pretty much translated as either Europe or, say, the United States. And the places that you could basically do stuff to were any of the places of the world, and not only your own places, but any other places in the world you controlled outside of your home area. So if you're England, for example, on one hand, you'd be very clear that your use of resources was to help the people living in England. But because you controlled almost a fifth of the world's population, you could also take all those other places and exploit their resources and ship those back to England. So places like Australia and New Zealand basically became resource generators for England, not for the people that lived in those two countries, or back in that day it would be territories or colonies. So in that context, this was starting to change, but to be honest, the political and sort of attitude climate was such that people didn't care. There's an attitude, if I control you, then I have access to your resources and I'm not worried about the consequences for you. And it's also important to remember that until probably the mid 20th century, no one paid any attention to the long-term consequences. In other words, time wasn't an issue in all of this. People only looked at the here and now and sort of thought about it in the context of, what is this for me or what is this for us? And we're really sort of totally disinterested in what it meant in a larger context. Let me give you one of the classic examples because this just turned into a real issue recently. Probably one of the most striking graphic examples of all this is the Nile River. So here's Sudan, Ethiopia's over here, and this is Egypt. And for millions and millions of years, water starts down here. And you can see this is the Nile where it starts, and it drains all the way down through here, all the way till it hits the Mediterranean Sea. And this entire area is incredibly dry. There's basically almost no rain in this area. So if you're going to get any sort of fresh water, the only water is from this river. So this river runs for, I believe, about 1,500 miles. And from basically that green spot at the other end on down, there's no water here except what you get. So you can see literally the river generates all this. Anything that's green here is coming from the river. Here's a little bit, they've done a little bit of irrigation. There's some over here. Now, when the human population moves into this area, they're not stupid. They realize very quickly that that's how this works. And so what you get is the development of the concept of places like Egypt is all based on the river. When Egypt becomes a state, a proto-political state back about 5,000 years ago, the power of the pharaohs, the guys that actually ran Egypt, was based on their ability to control the river and predict the rise and fall of the river on a yearly basis. So the entire basis of Egyptian civilization, the temples, pyramids, all that type of stuff, was based entirely on the Nile River and the water it brings and control of that. And that's still Egypt in the 21st century. So, until basically the last 80 years, the Nile River just did what it was going to do. And there's actually very important, very complex reasons for that, because every year what happens is the river up here floods. And in the flood season, which I'm going to guess is the spring, but I'm just sort of making this up, so I'm not too sure. What happens is huge amounts of water come down, as you imagine with the word flood, come down the river, and the whole Nile rises up to about maybe 10, 15 feet above where it does normally. And what it does is it not only spills huge amounts of water all the way here until it dumps into the Mediterranean, but also dumps huge amounts of dirt. So this whole area gets covered in mud. Now, that actually was a real advantage to this area because you don't have any fertilizing systems. So all this soil that comes down from Central Africa is very, very rich. It's very fertile. And so if you're a farmer living here, you survive on the floods of the Nile. The Nile floods, when the Nile floods, sure, yeah, for a little while, the whole place is covered. Your whole place is a swamp. It's covered in water, it's covered in mud. But then when that starts to dry out, you immediately plant in that mud, and now you've got your fields for the next year. They've already got water in them, they've already got new dirt in them, and so you're going to get these amazingly rich harvests. You're going to get a lot of food, and Mother Nature's done the whole thing for you. All you got to do is when the floods happen next year is you make sure you get your butt over here where it's dry and watch the waters come in and flood the whole place. In the middle, it starts to dry up and go running back out here and plant your fields again. And this cycle is how people have been doing agriculture for about 9,000 or 10,000 years. It's incredibly efficient, it's incredibly successful, and it's entirely run by Mother Nature. Now, in the late 20th century, Egypt decided, among other things, that what it was going to do was in part industrialize. So prior to this, what you just had was farmers, and farmers lived out here, and they just put up with the floods of the Nile because they weren't stupid. They realized that the floods brought the dirt and brought the water that made food possible. They were not starving to death because the Nile fed them. And that's exactly the way they saw it, and that's why they gave the power to guys like pharaohs back in the, really long ago, because they positioned themselves as the guys who could control the water. And you don't want to mess around with someone like that, because that's a little of your life. You'll live or die based on this river. But when they decide to industrialize, and what that means is several things. It's things like railways, it's things like paved roads, all these type of things. It's things like factories and now solid types of houses. And what you also start to do is you start to think of the river not only as water, but you also start to think of the river as transport. So what you do is you start running boats up and down the river, which you always have. Now you run big steamboats, and now you start to think about having factories and hotels and roads that cross, like this road crossing here, and all this stuff like this. And now what happens is when you start to look at this way, looking at the world, then all of a sudden when the Nile floods, it's a hassle. When the Nile floods, this road gets covered in dirt and water, and so you can't use it for a while. If you've got a factory over here, now it gets flooded out. And so pretty soon what you get is more and more people saying, this was really good back in the day when there were pharaohs running around 5,000 years ago, but you've got to control this flooding because it's making life really a hassle. Mind you, it's only making it a hassle because you change the way you do stuff. But sad to say, in the short period of the term, they didn't think about that too much. And also one of the sort of ego things that countries get very into is architecture. Building big things becomes a way that a country can say how important it is. And so what happens is in the 1950s, 1960s, I don't remember exactly when, the Egyptians decide they're going to control the Nile. And so what they did was, with Russian money and Russian engineering, they built this absolutely massive, massive, massive dam called the Aswan High Dam. And for the first time in millions of years, the Nile's corked up. Now, they initially, for some reason, you got to wonder why, because anyone with half a brain would have been able to tell them this. And they knew it from their own history. But they were so fascinated with the idea of building the world's largest dam and controlling one of the world's most famous rivers that it's sort of like, everyone's ability to think just got dumped out the wall or something like that. So they did it, and they built it. And now they could control the amount of water going down the Nile all the way to the Mediterranean for almost 800 miles to the north. What they didn't figure out was several things. What they were hoping, and what they got, of course, was this enormous lake, which is all the water that normally would have gone down the Nile. Now it's dammed up in this huge lake, which they figured, then we can tap this lake and we can use it for irrigation and agriculture. The only problem is if you look at the shape of Egypt, given where this water is and given where all the people live, which is up here, it's not a particularly good fit. You have to run the water for hundreds of miles to get it to the people that want it. It's not a practical solution in that regard. Most importantly, it's somewhere along the line, they forgot the other thing the Nile used to do, and that was that it brought mud. Now, if you've still got all the water pouring down from up here in the mountains in Central Africa, what happens now when this water hits this dam and stops? Where does the mud go? Visualize for a second. Here's all this water just coming down here, millions and millions of gallons, all brown, all covered in just almost mud, dirt, water. It hits this dam and comes to a stop. What's going to happen to the dirt in the water? It's the only thing that can happen to it. Where's it go? I'll give you a hint. Look at the color of the water here. Look at the color of the water here. Why is this water lighter colored than this water?
Is that all the dirt?
That's all the mud, yeah. It's just collected behind the dam. They have three huge dredges the size of massive skyscrapers out here working 24/7. That might be one of them right there. Doing nothing but dredging this thing out, because if they were to leave it alone, they realized this the minute, by the time the dam was done, they already knew this was going to happen. And the idiots just decided they were going to keep on building it anyways, because it was such a prestige thing to show that Egypt was a great country and could build a huge dam. It was, in fact, the Egyptians, the government pushed it as the 1950s version of a pyramid. So it's sort of like the great new way to show that we're a big country because we can build this stuff. But they realized very quickly what was happening is the dirt was filling up to the extent, if they had not started dredging this out by the time the dam was finished, by the early 1960s, there would have been so much mud that this would all been filling up. The water gun would have spilled right over the dam, tore the whole dam out. And you're probably ended with about an 80 to 100-foot flood all the way down to the Mediterranean, and the whole thing would have been erased. Would have been the world's largest dam collapse. So ever since then, they had to madly dig out this mud and then figure out what they're going to do with it. That's what all this property is over here. A lot of the stuff here has this funny yellow color. That's actually dirt that was in here. They just literally take it by truck and dump it 24/7, 365 days a year, madly dumping this dirt out. So the next year when it floods, the water gets up right to the edge of the dam, but with all that mud there, it doesn't spill over. So it's one of those classic catastrophes that's just, when you look at it, it's just sort of like, what the hell were you people thinking? Okay. Now, what makes it now a global issue is, as of 5 years ago, I believe down here, that might be it, yeah, there it is. The Sudanese decided to build their own dam. Now, this is a different country. The Sudan and Egypt don't like each other. Okay. Now, the Sudanese have done a dam. Notice I did exactly the same the Egyptians did. They've corked the river, and they've got a nice big lake here. Now, why did the Egyptians get all upset about this dam? You have to visualize the water's starting here and it's going this way. So the water's starting here. If you want to think, the water goes from this dam, it goes up to the Aswan Dam here, and then eventually goes up to here. Why are the Egyptians hyperactive? In fact, they've threatened, and they very well might by the end of this year, they have threatened to bomb this dam right out of existence, to literally blow it up, to declare war on the Sudan and blow the dam up. Why are the Egyptians so hoo-hoo? See if you guys can figure it out.
Wasn't it obstructing the flow of the river for the Egyptians as well?
Yeah, yeah, and the reason the Sudanese built the dam, their dam is built in an area with, if you notice, there's no particular towns around there. There's not a population particularly. They built that dam intentionally to turn off the faucet to Egypt. They built that dam and then told the Egyptians, if you piss us off or give us attitude or don't do what we want, then we're just going to shut this sucker down, and this is all going to be dry. And then you're going to have the world's largest dry lake full of dry mud, and you're going to have no water here, and everyone's going to die of thirst, because the only water in all of Egypt comes from the Nile River. This is the huge problem right now, is there's 8 different places in the world where countries are building dams for actually the sole purpose of controlling water flow to neighboring countries, so that they can basically do this as another form, just like having nuclear weapons or a large army or anything else like that. It serves exactly the same purpose. It allows you to control the way that you deal with your neighbors. Israel is one of the most famous for this with Jordan. 2 of the rivers in Israel go through into Jordan. In both cases, the Israelis have put dams in, theoretically for agriculture, but one of the other major functions that allows them to totally shut off all the water goes in the country of Jordan, which means, again, they would have no fresh water. This is a very common game that's being played. The Chinese right now are in conflict with India. It might turn into a shooting war next week. The Chinese just did a massive increase in troops a couple of days ago. And one of the things the Chinese are doing is they're building a huge number of dams up here in southern China. And the reason is they want to control all water flow in all of Southeast Asia. All the waters that flow through places like Malaysia, Burma, all that water, with the exception of the Ganges, starts here in China. In fact, you can see here it is right here. This all starts in China. So if you build a huge dam up here, you can control water to 8 different countries. And at that point, you can tell them, you're going to buy Chinese stuff, or you're going to listen to us, you're going to let us tell you what to do, because if you don't, we'll just shut the water off. So it's sort of the same reason why if you guys own a place, you got to pay the board of water supply, because they shut your water off, you're going to die of thirst. This is one of the huge strategic games that are being played in the 21st century. And what it does, it brings to mind the fact that for much of the world, there's no real attitude at the fact that these guys are all part of the same part of the planet. They are, obviously. I mean, you can see it on Google Earth, and you can, with half a brain, you can literally fly over and you can see it when you're there. And anyone can notice that this river starts here. But rather than seeing this as a way where they can cooperate and accept this as a common thing, what you find is the different populations that have this will rather control that for the purpose of not sharing. And this is one of the huge problems. The United Nations points out probably accurately that the major force for war right now in 2020 is going to be access to water. It's not going to be access to some sort of resource or political discussions. It's literally going to be someone decide that they're going to do this threat and basically just whack someone else. One of the classic examples is actually here, and this one's really sad because it's just a case of literally just combination of disinterest and largely ignorance. Here's the United States. Here's the Colorado River and a subsidiary river coming down. Till roughly 100 years ago, these rivers, largely Colorado, flowed into here, and this whole area here was one of the richest areas in Mexican agriculture. Thousands and thousands of people lived in this area, and it was incredibly rich and incredibly fertile. You can still see what's left of it here. If you go through this whole area, what you're going to find is there's literally tens of towns that are just gone. Here you can see one right here. This all used to be farms and people. What happened starting in the early 20th century is the United States started to build dams. It's sad to say in this case, there really wasn't a lot of political thought attached to it. In this case, it was just a matter not even of controlling the river. The Colorado River really didn't flood in a lot of areas where a lot of people were impacted, so it wasn't like the Nile. The main reason was that, one, you could do it. Again, it was engineering, it was ego. But it was also the idea of hydroelectric power. So if you dam this sucker up, the main reason you do this initially was to generate energy here. And it was seen as a free and easy way to do stuff with relatively minor impacts, because there really wasn't anything down here that interested anyone in it very much. Then, of course, what happens is you start putting dam after dam in this whole system. Here you can see the flooding of the next one. So you start to put more and more dams across this whole thing to literally start controlling the entire river flow. What then happens is when you've got these huge lakes of controlled water now behind these dams, you then take that water, and what you do is you actually tap it. So then you're thinking, well, hey, we've got all this water hanging around. It's not doing anything useful. We get the power out of it, but it's just sitting here. So what we'll do is we'll actually run pipes and basically take this water and use it to provide water in areas that don't have it. All this area here is high desert. This area gets about 10 or 15 inches of rain a year. What you do if you're Las Vegas or Los Angeles or any place to the west or to the east is you take that water. In the case of California, you literally take that water here and you move it all the way over to here. So if someone's turning their sprinklers on in LA, or they're using a pond for their kids or something like that, or they're washing their car, that water originally came over 800 miles to the east in the Colorado River. And that allows you to have California. Most of California's water and the agriculture and all the stuff like that is all based on water that's from hundreds of miles to the east. In fact, there's this enormous system of aquifers. You can actually see these things. This is massive system of drainage canals and largely drainage canals running east. It's very inefficient. It's very sloppy from an environmental standpoint. And to be honest, they didn't care. And that's how LA got built. LA got built, the Mulholland system got built entirely upon the water from here. Now, what happened is that in the last 50 years especially, is not only do you have the water that California is using, but the enormous growth in populations in places like Las Vegas, an enormous growth in populations of places in Arizona like Scottsdale. So what's happened is the number of people that want the same water has gotten completely out of scale to the water. So ironically, you now ended up a situation you would have to dam up every inch of the Colorado just to have enough water for anyone to use. And even then there wouldn't be enough water because it's getting tapped further and further north, and so they're short of water. It's estimated by 10 or 15 years from now, the western states are going to be short of about 20% of their needed water supply. Not so much because the population increased, but the things that people are using water for has increased. The amount of water we consume daily has gone up dramatically in the last 60, 70 years. And there's just not a water available because it all pretty much comes from this one source. Now in this process, by the 1930s, 40s, when they put all those dams here, just like they did in Egypt, and here's the last part of the United States here, is what they put the last of these dams in just north of the Mexican border. And at that point, they shut this down. And if you notice here, here's the Colorado River. This thing used to be one of the world's larger rivers. Now it's completely, totally, except for one aqueduct, dry. And if you notice, the Mexican aqueducts are actually not even aqueducts anymore. They're actually totally dry. That's what's happened. The Colorado River no longer flows into the ocean. Colorado River used to flow into here at Baja California into the Pacific Ocean. Now it doesn't anymore. It actually stops 150 miles north. It stops right about here. One of the world's larger rivers doesn't even make it to the ocean anymore. It's completely sucked up by dams and systems like that. This has enormous environmental consequences. One pretty obvious is all of a sudden all the farmers in Mexico are screwed because the water is being used by another country. Unlike the Sudan and Egypt, this wasn't intentional in the sense the United States intended to screw the Mexican farmers over. But on the other hand, they didn't care because they were Mexican farmers, so who cares in the United States? Mexico has been trying since the 1930s to get the United States to release sufficient water to at least have it flush out into the Pacific. And the United States can't do it because farmers in California, Arizona, and stuff like that, Las Vegas wants its water features at the Bellagio, all those things require Colorado water, and no one's willing to share. So what you get is this classic example of regionality, where everyone's sort of thinking, I want this, I should have this, this is in my front yard, so it belongs to me. And you have to remember, in most places, this is true in the mainland United States, you can actually own water. If you live in someplace like Nevada or Arizona, you can, someone like Emily can actually buy shares of water. Just like you'd buy iron or gold or anything else, you can actually buy water. In the sense of buy part of a lake, you can actually own part of a river. And then you can sell it to other people. You can sell water rights. Now, we don't have that here in Hawaii because of monarchy law. Theoretically, in Hawaii, all fresh water belongs to everyone. But we're unique in the United States in that regard. All the other states have water rights in the sense of water, in the sense of you can buy it right. So you actually put a cash value on water and can actually buy and invest in water. This is a big thing in the mainland in the West. There's huge companies that have made literally billions of dollars out of controlling water from the Colorado. And they're worth, and then they basically, they can never, how can they ever go broke? As long as there's people and they're thirsty, they're always going to be making money. So this is sort of the other type of regionality where we don't even think about the consequence of something, because in the short term and for your purposes, there's enough in it for you right now that you're not interested in the impact it has to someone else. But if you're Mexican and you live in this part of Baja California, you get pretty bitter when the word American shows up, because your dad or your grandpa used to have a farm down here and he used to productive ranch, and he probably was ironically selling the oranges in LA or something like that, and now you got nothing except dirt. So it's a very complex thing when you look at the idea of regionality or small scale versus the alternative, which would be the fact that the Colorado starts up here and it goes all the way down here and ends up here. This would be what's called the Gaia concept. The Gaia concept actually originally, the story comes from the Greeks, which just had the idea that the actual Earth was actually a goddess. So it actually was seen as an organism. The Greeks never really got into it in a sort of a theoretical way. They just sort of had it as one of their myths or something like that. It wasn't until the sort of mid-20th century when, ironically, guys looking at the atmosphere in terms of global pollution, air pollution, started to realize that if you have, a good example would be Chernobyl back in the 80s, the Russian nuclear power plant blows up, or Fukushima back, about 15 years ago, it blows up. And that global spillover of polluted, radioactive material isn't going to stop at the Russian border. It's going to cover everything. And so the realization, I think, first happened to the atmosphere guys when they realized that the whole planet is really one system. You might be able to look at discrete parts where the Colorado River starts here and the Colorado River stops there. But the fact that the Colorado River doesn't flow into Baja California means that the water temperatures here are about 15 degrees warmer than they were 100 years ago, which is one reason why there's more hurricanes that spawn off of here, because the water's so much hotter. So to a certain extent, if we get hit by a hurricane or someplace here gets hit by a hurricane, in part it's because the fact that Colorado River doesn't run the way it used to. So there are consequences hundreds or thousands of miles away from doing something. And we understand that in a technical level. Anyone who's in environmental studies can tell you this till they go, blue in the face. But in the standpoint of politics, national interest, regional interest, and stuff like that, it's a non-player. This is probably one of the huge changes that has to occur intellectually, is this idea that you have to move from each place or region can do whatever it wants to a more global concept that we all exist on the same planet. If you overpollute or make something toxic in one spot, it very likely is going to make things toxic in another place too. But that's the hardest thing to buy into, because ironically what you find in the last 5 years especially is that much of the world's population is getting more and more tied to local. So people are becoming much more ethnic, they're becoming much more nationalistic, they're much more aggressive about that. The United States is a good example. And so what you find is it's much more difficult than it was even, say, in 2010 to discuss the reality of the idea of a Gaia concept, where you have to look at the planet as one ecosystem. And everything in the planet has to coexist, because there's actually only one basic aspect of resources. And this is why you see the total disconnect when it comes to things like global warming. You can even have all the data to support it. It doesn't make any difference, because people are going to say, well, that might be true, but it's not my fault because I didn't make it happen. Well, it might not, but you're going to be the consequence of it. So. Second part of this is real straightforward, which you hear all the time and should be, but it's not quite as simple as with most things as it seems. What's an example of a non-renewable resource? Since that's the easiest category.
Something that can't be restored.
Yeah, something once you've done it, the bugger's power. So every time you take your car, your moped, and drive around and it's using gasoline, it's gone. The gasoline's not going to come back, to suddenly magically reappear in the Texaco pump next week. It's gone. Now it will eventually come back. If you're a geologist, then the most non-renewable resources actually aren't. In about 10 to 20 million years, yeah, you will get new groups of petroleum show up. But for the foreseeable future, since the chance of human species being around in 10 to 20 million years, I know we're not going to be around then personally. So for us, it's non-renewable. So this is something, once it's been used, it's gone. Okay? And it's off the plate. As long as your non-renewable resources are one fairly small in amount, and you're fairly conscious about the fact that they are non-renewable, then you're okay. When you get, as in the United States is probably the worst in the world in this regard, when on the other hand you use non-renewable resources and you really have no interest or concern about the fact that they won't be around, it's sort of surrealistic, especially from a geographer standpoint. There's just sort of a disconnect, especially in the United States, that if you use up a resource, then it won't be there for your kids. If you talk to Europeans, they're much more aware of this, and I'm not particularly sure what the difference is, but if in Europe, people talk about using paper bags instead of plastic bags, and they'll usually frequently say somewhere in there, because I want to make sure that there's something left for my children. In the United States, you don't hear that discussion. It's entirely absent. Americans will bitch about using paper bags because they're not as strong as plastic bags. But the idea that of course plastic comes from what? Where do plastics come from? Do you mine for plastics?
Is it petroleum?
Mm-hmm. Same thing you get gasoline from. So it's the same situation when oil comes out of the ground. If it comes from Saudi Arabia, or if it comes from fracking in Ohio or something like that, it comes out of the ground, then you decide what you want to do with it. You can turn it into kerosene, to diesel, to gasoline, or into plastics. So all of that stuff sort of starts in the same place. And they're all basically non-renewable resources. Now, if you actually have an enormous amount of energy, so if you use a huge amount of heat and stuff, you can actually turn plastics back into oil. But the amount of energy you use actually takes up 5 times as much energy as you would if you just buried the plastics. So it doesn't make any sense to do it. Really, from an environmental standpoint, it's an incredibly bad idea of recycling, to recycle plastics if you're trying to turn it back into fuel. If you're just trying to turn plastics into another type of plastic, which is pretty straightforward, that's actually a lot easier, though it's still not necessarily particularly responsible. So non-renewable, yeah, non-renewable is sort of scary because when you actually look at it, it's really straightforward. It's real obvious. There's no disagreement about how long it takes for rotted plants, for example, to turn into petroleum or oil. The amount that's there is pretty straightforward. Natural gas is exactly the same thing. So when you're looking at these, this is also one reason why this is such a huge issue in a lot of the planet. Right now, of course, the big flashpoint is this area in the Western Pacific. Philippines over here, Indonesia here, Malaysia, Vietnam, China. This is considered to be one of the world's largest natural gas and oil reserves left. It's in these islands in this part of the South China Sea. China in the last 10 years has now turned 8 of these islands into forts, which is actually illegal. This is supposed to be open seas. They're not supposed to do that. They promised they weren't going to do it, and they're doing it. They've now threatened to shoot anyone who goes into this area. The United States is sending ships on a weekly basis, intentionally daring them to do it. The Philippines just yesterday said that it's going to start sending ships in to fight the Chinese if necessary to get them out of this area. This is a classic example of everyone wants this resource because it's non-renewable. So if you've used up all the oil, basically none of these countries has access to other oil reserves. The only oil that they can have, that they could then sell or use on their own, would be the oil that you're going to find in this region. Now they could basically say, okay, we're going to split it up. You guys get this amount, we get this amount, whatever. But none of them want to share, especially China. So they're basically saying, we want the whole thing. You guys can just go, kiss it goodbye. We're not going to give any of it to you. This is right now considered to be, someone's going to make a mistake really soon. The United States just sent another aircraft carrier down there last week. The Chinese now have 20 or 30% of their long-range missiles down here. Everyone's watching everyone. Everyone's getting ready to shoot everyone at a moment's notice. And the interesting thing about it is if you do that, as many people have pointed out, that no one's ever going to get the resource. This is considered the most likely region for World War III to start right now, is this area. And it's over access to a non-renewable resource.
Are you showing something right now?
Hmm?
Are you showing something?
Oh, I'm sorry, you guys. Sorry, I forgot to switch it. Okay, here we go.
No worries.
Yeah. Here's the Spratly. So here's the Philippines. Here's Indonesia. Here's Vietnam, Malaysia, Singapore. China's here. This is what they're arguing they should all get. Now, there's actually no real land here. These are all very small pieces of rock that just stick above the water. But now in the 21st century, this has become the most likely spot for World War III to start. The other likely spot, ironically, is just slightly to the north and involves China. China's at the middle of most of this mess, in one way, shape, or form. And that's actually right here. This is another large oil gas reserve. The Japanese claim it. They actually have control of some of these islands. The Chinese want it. The Koreans want it. Taiwan wants it. So you've got 4 countries that want this for exactly the same thing. This one doesn't seem to be quite as escalating. It isn't escalating as quickly. But still, the Japanese, just a couple of days ago, turned attack radar on Chinese jets flying through here, and you turn attack radar just before you fire a missile. So basically, this is another area where if one person presses the wrong button, it could go south in a hurry. It's exactly the same thing. It's access to a non-renewable resource of which there are limited amounts, and the world's using up what's available very, very quickly. So the places that have this stuff left are in very short supply. And so in that context, controlling these has become absolutely critical in the way the countries see their personal future. In the case of China, China's not interested in the countries around it. It wants this for its own needs. And that type of sort of self-serving self-focus is the antithesis of the Gaia concept. which would be that you'd figure out how you can keep this resource intact, use as little as possible since it's non-renewable, and benefit as much of the population of this part of Asia as possible. That's not the discussion that's happening. So this is typical of the type of problems you get into with the idea of renewable and non-renewable resources. Now the renewable part's a little trickier. Let's see, I have a good one for that. So renewable resources, a good example would be paper bags. Paper bags come from a modified version of a pine tree. They're called paper pines. You can find these are large. These aren't huge, 100,000 acre plantations in the southern parts of the United States, like Georgia and Tennessee and stuff like that. You'll just find literally, drive for almost hours and see nothing but these trees. And all these trees are about the same size. And they'll grow incredibly quickly. They almost grow like weeds, almost like an albizia. I think you can probably use albizia for this. And what you do is you get the trees to a certain size, you cut them down, and you grind them up into pulp, and then you turn the pulp into paper, and that makes a paper bag. Okay. So on one hand, this is considered a renewable resource. Why? Why is that paper bag different than a plastic bag?
Can keep like growing more trees or whatever, and keep getting paper.
Yeah, I mean, you could cut down that tree and plant another tree in the same spot, and within, I think, 7 or 8 years, bang, you got another tree and cut the bugger back down, you're all back again. So on one hand, it's renewable. But on the other hand, there's an enormous amount of energy when you cut a tree down, when you grind it into pulp, when you press it into paper, then you turn that paper into a bag, then you ship that bag to Hawaii, for example. So renewable resources in many cases really aren't near as renewable as they look. They have the advantage, they make people feel good because they feel like they're doing something environmentally responsible. But in many cases, they're not really as environmentally responsible as they appear. This especially when you involve things like recycling. If you recycle paper here, we actually don't. If you put stuff in your paper bin, your green bin, there's a blue bin here in Honolulu, that actually goes to the H-Power plant in Kapolei. And the reason is they were actually packing that stuff on sending it by barge all the way to China to be turned back into cardboard again. But if you figure out the environmental cost of using fossil fuels to ship a pile of paper to China and then ship it back as paper, which is a total of 10,000 miles back and forth, you're spending an enormous amount of non-renewable resources to make a resource renewable. So a lot of the issue of recycling resources and the idea of renewability really doesn't have a particularly valid argument. If we go back, if you want to see this in an easy way, I forgot it, I don't have it down here. Go and Google the concept of carbon footprint. Because that's actually a measure that's come out, which basically shows you how much energy is involved in making something. And if you're going to do something else with it, how much energy does that involve? And it's really pretty shocking when you look at it, the things that people think of as being renewable that actually have very large carbon footprints. And some other stuff that doesn't. For example, it'd be very easy here to turn things like palm fronds into paper. They used to do it 100 years ago, but they quit. So if you did that, you literally could take something we have as a growing resource here, grind into paper for much lower cost, turn into paper bags or something like that. Or if you knew how to do it, you could actually weave it. The hala and palm frond baskets are more common. They still are in, say, Samoa or Tonga, someplace like that. It's not that hard to learn how to do it. I used to know how to do it, I forgot. But you could do it. We've got hala trees all over campus. So there'd be ways you can actually do that. But that's not, when people think of renewable, they don't usually. They go to someplace like Whole Foods and they get a paper bag for their food. They think of that as a renewable option. But it's not necessarily quite the way it appears. And this is true of a lot of this type of stuff when you're looking at recycling, renewable. Take a look at the idea of carbon footprint. There's some really, really good videos on YouTube, especially United Nations. Some other folks put ones out of actually showing the footprint of stuff. If I can find it, there was a really good video done a couple of years ago on the whole issue of consumption. That's pretty chilling. And I'll, if I remember, I'll try to see if I can find it for you guys. Write that down somewhere. Give us a Okay. So the last one of these is this idea of energy sources. Some of these should be pretty straightforward. we went over this before. I think I was asking you guys what type of classes you took in high school. Do you guys take some sort of like environmental studies class in high school, right? I got
I
two
think it
people nodding, and
depends.
everyone else is looking at me blankly, and everyone else got their picture turned off, so I have no idea what they're saying. I'm sorry, Peyton, what did you say?
I think it depends. I don't think it's like required.
Really?
But I think you can like choose it as like your third
Science.
year science credit or something. Yeah.
Oh, that's pretty
I
lame.
had to take it.
You did?
Yeah, it was environmental systems and societies.
What year in high school?
Yeah, third and fourth, both years.
For 2 years.
Yeah, because IB is like it's a 2-year program, so they made us take all of these like.
Well, that was part of the one you were telling me about before.
Yeah, so IB was so geography was different from environmental systems, which it was kind of the same thing in a way, because
like this, it crosses over. Yeah.
Yeah.
Okay, so it's an option for most. It's an option for folks. So basically, you guys could go all the way through high school and never have any exposure to environmental issues, unless you choose to do so. Man, that is scary. Okay, well, that explains why no one knows anything. Not you guys in particular, but sort of general population. So okay, energy sources. Well, I guess I better go through this then. Energy sources, there's a bunch of different types. Some you're probably familiar with. You see them all the time in the media. Other ones probably not so familiar with. Fossil fuel is one of the most obvious. That'd be a coal power plant. The Kai power plant was coal. It got converted to oil, which is still a fossil fuel. Liquid natural gases, which is what they're using in Europe because it's less polluting. It's actually a less efficient form of energy, but it doesn't have the same pollution issues. So Europe's largely converted to natural gas in many areas. Active passive solar systems, these again are pretty straightforward. Passive solar systems, I assume you're familiar with. That's solar panels like I got on the boat, like the solar panels I've got at home. Those are the things you see on most people's houses. That will also involve, for example, solar heating of things like water, so that you don't use fossil fuels to do the same thing. So that's you're probably fairly familiar with. Active solar systems are a little bit trickier. These are really quite rare. Active solar systems are where you use solar energy to actually move something, and that process makes something happen. This is pretty much at the very sort of theoretical stage now, because solar energy is one of the great potentials for folks that are worried about environmental impacts, because solar energy is something the planet gets anyways. So if you can figure out some way to convert energy that's just heating up a pavement to do something more useful, then you're actually not using any sort of a, well, very little in terms of non-renewable resources, for example. But the active one's still pretty iffy. Hydroelectric would be what I was talking about earlier with dams. See, basically, since water flows downhill, if you just put a thing like a set of propellers, a turbine in between, you control the water, put a turbine in between it, the turbine spins, the turbine generates electricity. So hydro to electric. This was the big thing in the 20th century. The United States became one of the world's most leading countries by virtue of cheap hydroelectric energy, which meant that you could put up factories, for example, and not have to build, a coal power plant. In Europe, they didn't have as much access to this, so they've had to depend a lot more. In Japan, you got some hydroelectric, but they're sort of in an iffy situation. The 12 Gorges Dam in China, its main function was hydroelectric. Geothermal would be what? You guys might have heard that if you're ever from the Big Island. What's geothermal energy? This would be the Puna geothermal plant, would be a good example. Okay, no one's going to volunteer on this one. Okay. Basically, if you go down into the planet, it gets hot. It's real things. Remember, I'm not sure if we should call it high school science, because now I have no idea what the hell you guys take in science unless you choose something like Emily did. But assuming you have some vague idea of the globe and it's all red and hot in the middle and it gets cooler if it goes towards the edge, which is us. So if you drill a hole into that, or you somehow access that hotter material, and you push water or oil or something else in there, it'll heat back up, boil back up, And as it comes shooting back out as steam or some sort of, high pressure gas, you then put that same thing with the turbines. So it works off a similar principle to hydroelectric power, except in hydroelectric, you just got water going downhill. In geothermal, what you're doing is you're pushing some sort of a liquid into an area where Mother Nature heats it up for you. And then you basically have that shoot back out and you spin that. And if you do it right, you can actually recycle it so it goes in a circle. The Puna geothermal plant is supposed to work that way, but that sucker has never worked right. So it has a real tendency to leak, which is not good because a lot of those gases are somewhat toxic. So my view would be, on one hand, the area around there, I've worked around in Poho a lot. It's an interesting place to go to, but I would make sure you stay upwind of the geothermal plant, not downwind of it, just because. Wind power, that should be straightforward. If you remember the whole issue on Haleiwa that's still going on right now. That should just basically stick propellers in the air and then watch the wind, whip the suckers around. Like solar, it has the huge attraction that basically is largely passive in the sense that the power is there, you're just trying to figure out a way to tap it. So it's more of an engineering issue than sort of a how do you do it issue. In fact, it's probably sort of the lowest tech of all these. They've had windmills in Europe and Asia for thousands of years. The three that are probably the most complicated, biomass would be what? They're actually talking about doing this in the Big Island with albizia trees, which would probably be a good idea. Which are these noxious trees that grow about as fast as a weed. You basically end up with according to a friend of mine, I haven't seen them because I haven't been back to Big Island in years. And you can basically get an albizia tree up to 15 feet in about 5 years, which is pretty creepy. So if you're going to biomass it, what are you doing to that tree? And I'll give you a hint. The first thing you do looks like we did with the paper pine trees. You cut the bugger down. Then what do you do with it? Now, this is only Thursday. I mean, it's only Tuesday. If it was Thursday, I'd give you guys a break because you don't have to think on Thursdays. But Tuesdays, you got to think. And Emily and Peyton can't say because they've already been doing all the volunteering. So we got all these other folks in class that are just like beans, like couch potatoes. Probably in some cases literary, because I'm not sure where most of you are sitting. So what would be biomass? Kayla's, I'm not going to pick on Kayla directly, but she's just cut down one of these albizia trees. She got it sitting in her yard. How does she turn that into fuel? Think of Christmas time. What's one of the images of Christmas? What do you put the Christmas tree in front of? Okay, give up. Anyone can answer. It's supposed to be snowing outside, and hopefully it's not going to be doing that here, but it's supposed to be snowing outside. You got a Christmas tree, the family's sitting around. What's on the side of the house next to the Christmas tree? What does Santa Claus come down?
Chimney.
Yeah. What happens if the fire is running? Santa Claus is going to have issues, yeah? Okay. So the fireplace, burning that fuel, burning that tree is a form of biomass. Okay. Now, we actually had that in a very elegant way here in Hawaii. If you ever go to the Punene sugar mill, I'm not sure if you guys have ever been to Maui, but if you ever go over there, it's a really drag that's been shut down. But one of the fascinating things about that is you look at it, it's an incredibly efficient system. Because what they did by the 1920s here, because labor was expensive and the plantations were trying to maximize the amount of money they made off of sugar, and they didn't want to pay for energy, is they realized that when you cut down the sugar cane, you end up with all the sugar stalks, which you guys won't see because we don't do that anymore here. You end up with literally, hundreds of acres of cut down sugar cane. You then, I was able to do this once. It's huge fun to do. Is you actually set a fire. I actually did this legally, I might point out. You set a fire and you burn off some of this acreage. What it does, it burns all the leaves and stuff off of there, but the sugar cane's still there. Then you go and you pick it up in these huge trucks and you go and you ship it off to the sugar mill. You then crush the sugar cane in these huge steel drums and actually squeeze all the juice out of it. And when it's done, you've got all these pieces of busted up sugar cane that you then spit out the other end. To make it work better, you actually heat this up while you're doing it so you get more of the juice out. So when this is done, in fact, you can see this in a little way if you ever go down to Chinatown or someplace else and you get sugarcane juice. The lady will go feed into one end, there's that thing that scrunches it up and the sugarcane's all gushed up and then the juice comes out the bottom and you got sugarcane juice. Obviously, it doesn't look like anyone's ever done that. I'll go to Chinatown, you can see it. So in that situation, what you've got is it suddenly dawned on some genius in the 1920s that you had this huge pile of leftover sugarcane stalks. And it dawned on them, if you go and you build a furnace, which you already had, and throw the sugarcane stalks into that, you can actually use them as the energy, the fuel, to heat up the whole thing, which then not only works the sugarcane, but then boils the juice to turn it into sugarcane or sugar, raw sugar. By the 1930s, unlike anywhere else in the world, the sugar plantations here were actually making all their own energy off of the sugarcane they were growing. It was a beautiful example of biomass fuel. By the 1940s, they were making so much energy off of the sugarcane, they were then selling the power to the counties. Now, this turned out to be a huge problem on Kauai and on the Big Island, because the sugar plantations there were generating almost all the power. If you lived in the Big Island, and even in the 1950s, and you turn on your lights, all of the power on the Big Island was generated by sugar plantations. You then sold it to the county, the Big Island County, as power. So the county didn't need to make any power plants. The plantations were their power plants, but it was all a side effect because the plantations were in the business of growing sugar. That was one of the side effects. It was an incredibly efficient, what we call closed loop energy system. They were growing the crops anyways. They got the sugar out of it, which they sold, so they're making money off of that. The leftover biomass, the plant, was then burned, which generated energy, which not only ran the plant to make the sugar, but also generated enough spare energy that they could then sell the power. In fact, when the sugar plantations shut down, the last plantations in Kohala and the Big Island were kept running, even though they weren't growing selling the sugar. They were literally dumping the sugar in the Pacific Ocean. But they were the only power plants for the Kohala part of the Big Island. So they kept them in operation for almost 10 years as power plants. So they're still harvesting the sugar. And you could go down there and just pick up the sugar. I used to pick up sugar when I used to live in Kauai. We used to pick up sugar from the Luli plantation. They weren't selling the sugar for much of anything. You literally go down and get a bag for free because they were making their money off of selling energy to the Kauai Power Conservancy. If you were on the Laihui side of Kauai, your power was coming from the sugar plantation, which meant that when the sugar plantation shut down, there was a huge panic because all of a sudden no one had any power. So on one hand, it was an incredibly efficient, probably in some ways, maybe a good example of sustainable agriculture, because sustainability wasn't just agriculture, you're also involved in energy production. But now, of course, it's gone, and it's not been replaced with anything. You could possibly do that with something else, but it probably wouldn't be as efficient because you had actually two revenue streams. You had the sugar and you had the energy, so you're making money two different ways. If you cut down paper pines or if you cut down albizia trees, you're only making money from the one thing, which is the energy. So it's not near as cost effective, but that's biomass. There's huge potential in biomass, especially in places like Hawaii, but it's not really been investigated because it's not particularly interesting or attractive or fun. And in many cases, it's actually pretty low tech. It's actually more to do with farmers than with like fancy engineering or something. Tidal surge energy. This is sort of a non-goer here because we don't have tidal surge. But if you look at some place, again, the best way to be is if you just Google this or YouTube it. If you look at areas with large amounts of surge, in a lot of areas, especially in the northern hemispheres, there's areas where you get maybe a tidal range of up to 8 or 12 feet a day. So if the water level in the ocean is here in one spot, at another point, maybe 5 hours later, it might be 5 or 6 feet higher. At another 6 hours, it might be 4 or 5 feet lower. Now, for some reason, it didn't dawn on people till about 30 years ago that if you had something that if it was moving up and down, it would generate electricity, you can actually use this natural function to generate electricity from it. The only ones that I knew they're doing this right now are the Dutch and the British. The British came up with the idea and started doing it in the 1970s on the Thames, which is one of the big rivers that runs into London. And they've got the system working, they're trying it. We've got 2 projects occurring off of Haleiwa. There's 3 units off there where they're actually trying ocean surge, in the sense of literally the swells doing the same thing, where you've got basically an arm that goes up and down. As it moves up and down, it generates electricity. So if you think it's like a version of wind power, so in this case, you're using water motion instead of wind motion. The Dutch are the only ones that are doing this commercially. And they've got 3 small tidal surge power plants that are, one's built and working, the other 2 are under construction. This again is a huge potential because you're taking something that exists totally naturally. You're just trying to figure out a way to take advantage of it for generating power purposes. The last thing, which I'll sort of finish off because I want to do it today before I forget, and that's OTEC. We're actually the world's leader in this. In fact, we're the only place in the world that's doing this. And I came up with a superb piece of graphic art here, which shows you how this works. Okay. Which you guys probably can't see. Sorry about that. Okay. Basically, OTEC looks like this. Here's the Big Island. I know you can't realize that, but that's because my art's so sophisticated, you just don't get it yet. So here's the Big Island. And you have to remember the Hawaiian Islands, unlike most places, go almost vertically. If you go off of Diamond Head down here, for some reason, I don't know, Montserrat's decided she's going to go swimming. So she goes swimming due south. So she goes by the Diamond Head buoy. If she goes out beyond the Diamond Head buoy is at 60 feet. If she swims out for another half a mile out there, she's at 900 feet. For some reason, she's real ambitious. She swims a mile south. She's at 2,000 feet deep. The Hawaiian Islands are basically vertical, and we go down about 6,000 feet, almost straight down. Now, what happened is it suddenly dawned on someone in the 1960s or 70s. When you dive down, does anyone do diving here, like free diving? You guys are such couch potatoes. Sorry, don't take that wrong. Anyways, if you were actually doing free diving, as you go down, one of the things you notice very quickly is you go down, you get pressure on your ears. Water pressure increases tremendously in very short distances. If you go about 800 to 1,000 feet down, the water pressure, I believe, is 30 times higher than it is at surface, which would mean that, for example, if it was like a beer can, the sucker would actually be crushed flat, just like stepping on it. Wait, gotta comment here. Why? You could swim that far. Jeez. People do the ocean open swim, they swim out way beyond the buoy. Yeah, you guys just gotta have more ambition. That's all I gotta say. Gotta have ambition. Or else just cheat and take a boogie board. Do the same thing, it's a lot faster. Or else am I ready to use my old style paddle board? So anyway, so what they did is they basically realized you've got the island going off here. And it dawned on them, we got this enormous water pressure down here. We'll say this is about 800 feet down. And it occurred to someone, if you somehow ran a pipe down there and you actually started to suction, just like it's, not that you guys have ever done this, but you're like stealing gas from a friend's car. So you go and you suck out, you take a hose, you suck it out, and then the gas starts to come out. Okay, so you've changed the water relation, the power pressure relationship. If you did the same thing, and they did this off, this is at Kailua Kona Harbor. What you do is you basically start a siphon process. Now you've got this water under enormous pressure coming up through this pipe because it now wants to release that pressure. And you know, this is almost like a perpetual motion machine. You've got the whole Pacific Ocean here. And what you've got is this water shooting up here incredibly quickly. All you do is you do the same thing. You take you can get this very sophisticated graphic here. You take this and you build a set of turbine blades in here. So the water comes shooting through, it spins those blades. And it's another version of hydroelectric power. Except in this case, all that happens at the top is you just literally, and then when they originally built this thing, I know because you were there helping them, is when they originally built this thing, you just ended up with this fountain of water about 60 feet in the air. It just looked like some sort of, you know, like a cheap pipe breaking on a street. And that was the water shooting out. But it was generating an enormous amount of electricity because the water was coming in here 365, you know, 24/7, perpetually, basically, because it just went and fell back in the ocean, just back in the totality of it. Now, you guys actually see this. I can't remember what they call themselves now. I think they call them deep ocean. But two things occurred is it dawned on some folks who are around living in this area that this water coming up from down in the ocean actually has some other ancillary possibilities. One is it's actually pretty strong in nutrients because it's coming from the deeper ocean, so it's fairly still. And so some guys who are raising prawns on the North Shore here, prawns like cooler water. And it suddenly dawned on one of these guys that if he went and took part of the parking lot, which with the fishing parking lot next to him, and turned that into a prawn area, and he actually took some of this salt water that was coming out of this thing and actually just moved it over and had it spray onto his prawn fields, he ended up with prawns just having a good old time, and he didn't have to feed them. Unlike the ones on the North Shore here, you have to feed the prawns. There he doesn't have to feed the prawns. The water feeds them. And the water wasn't going anywhere anyway, so who, you know, no one cares. The second part, which is really weird, which has to do with sort of the human species in general and how mental we are, is that some Japanese guys looked at this and decided that, oh, this water is actually really pure because it's 800 feet down. I don't know why they think that because it's still part of the Pacific Ocean. So what they do is they take this water, they distill it and turn it into fresh water, and then people buy this. Now, this was called Kona water for a while. I think it's called deep sea water now. I just saw a truck go by a couple of days ago. This was hugely popular till a couple of years ago in Waikiki. There was a couple of stores selling this stuff. It's still really popular in Japan. If you want to give omiyage to someone in Japan, take some bottles with you. I think in Japan, a bottle of this water, this distilled, quote, fresh water, unquote, costs like $30 or $50 for a bottle. It's hugely popular as an omiyagi for folks in Japan. And they buy cases of it here in Hawaii to take back for friends. Now the goofy thing about it, if you know anything about chemistry, the minute you distill the water, you take out whatever's in the water anyways. But for marketing purposes, Japanese have become firmly convinced that water from the deep ocean is more pure and better for you than water from the surface. So now what you've got is they were actually going to shut this facility down because it was actually a testing plant. They wanted to prove it would work, and it works superbly. We could have 10 or 20 of these things up now and generate almost all the power the Hawaiian Islands need for absolutely no environmental consequence. And on top of that, the prawn guys would be hugely happy because they're making enormous amounts of money off of the prawns, and the Japanese distilleries would be hugely happy because they're making tons of money off of Japanese drinking water for some weird reason. Okay. So we're not, because the power company HECO refuses to have anything to do with the OTEC thing because they wouldn't control the power consumption. They wouldn't make any money off of it, so they won't do it. The state won't push it for whatever set of reasons I don't understand. So we're the only place in the world that has OTEC, ocean thermal energy conversion, and it means ocean thermal energy conversion. It's a fascinating area. It has enormous potential, but only in areas which have deep waters very close to the shore. And we're not unique in that regard, but we're the most obvious places for it. So that's our different energy sources. So feel free to go see if you can find out who those water guys are. I can't remember what they call the water right now. But if you find a bunch of bottled water, and the bottled water is something like deep ocean or ocean depths or something like that, and it's going for like 25 to 50 bucks a bottle, then that's these guys. So don't tell me I didn't ever give you guys some entrepreneurial possibilities. There's a huge market expansion here if you just think about how to do it in sort of weird ways. Okay, we all set? Is that enough to bore you guys with for a day? We all good? Oh, okay.